without further ado, I'd like to take the opportunity to introduce our next speaker, Thilak, who was going to be talking about illustrating the simplicity of testing in Go and how one could quickly write unit tests by using the standard packages like testing, HTTP tests, and using things like HTTP testing to minimize third-party dependencies. Thilak, again, thank you and welcome. The floor is yours.
Thank you. Just give me a moment to share my screen. All right. So hi, everyone. Hope everyone is doing well today. My name is Thilak Subramanian. Today, I would like to talk about simplicity of testing using Go language. Through this talk, I would like to share my experience of having done test automation in other languages like Java, JavaScript, and I want to compare it to what it takes to write automated tests using Go language. Okay, so with that, this is what I'll be covering today. I will talk about how you can write and execute tests using Go language, and I'll briefly compare it to Java. And I will also tell you what kind of support Go programming language provides to write tests beyond unit tests. And in the end, I'll wrap it up with a short takeaway. And we'll have 5 to 10 minutes in the end for any question and answers that you have. So we'll have a Q&A at the end. So please make a note of your questions, and we'll have a Q&A at the end of the session. With that, again, my name is Thilak Subramanian. I am an engineer in New York Times. In New York Times, I'm in a team called Developer Platforms within Delivery Engineering. My team is primarily responsible for CI/CD tooling and general dev tooling. Currently, I'm leading an internal dev tooling project. Prior to joining New York Times, I have managed teams responsible for test automation and CI/CD in general. When I say CI/CD, I'm talking about tooling related to SEM, Artifactory, Jenkins, and also helping developers build their pipelines and also helping developers to debug their pipelines. So that has been my area of focus since the past decade until now. All right, so with that, we will get to the core of the presentation. So if you have done test automation in other languages like Java or frameworks could ring a bell. For example, in Java, you could have used a framework called JUnit or TestNG. When you write unit tests, mocking is a very crucial thing. And you could have used a framework called Mockito or PowerMock. And if you want to mock external APIs, you could have used WireMock. And for code coverage in particular, you could have used something called Jacoco to generate the code coverage reports, and you could have used a tool called SonarQube to view those code coverage reports. And when you write tests, I'm sure you are familiar with test assertion. So in Java, I've listed a couple of popular assertion libraries like Hamcrest and AssertJ. So you could have used these things. Typically, when you want to run your unit test, or in general, when you want, you would use a build framework like Maven when you want to build and create your package. So through Maven is how you would typically run your test. So this is all something related to unit tests. But when you want to write API test for your REST API test, Rest Assured is one of the popular testing framework that's out there in the Java community. So let's see what it takes now to write automated tests in Go. Yes, you're right. All it takes to write automated tests in Go is just the Go programming language. I will tell you, I'll give you the details as to what kind of support the programming language provides. But out of the box, the Go programming language supports everything that you need to write automated tests. It is true that it doesn't provide in-depth support for assertion libraries and frameworks that we saw in the other languages, but that's something that was done intentionally by the Go community and Go developers, because you don't need another framework to do your test assertions. You could have simple Go code, if-else statements, and write your test reporting, whether you test pass or fail. Because your test code is nothing different from regular Go code, and that's a very common, that's a Go philosophy, and I completely agree to that. Okay, so in this section, we'll talk about what it takes to write tests in Go. So I will be briefly covering some of the features that the Go language provides. Next slide. All right. So support for testing through Go standard library is provided by a package called testing. So in order to write automated tests in Go, all you need to do is to follow 3 simple rules. First rule is you need to have your test file called hello underscore test as an example that I've given. You need to suffix underscore test to the name of your test file. The second rule is your test needs to start with the word test followed by a capital letter and the name of your test. In the example that I've given on the right, you can see I have 2 tests, test hello and test world. And the third rule is your test needs to take a parameter of type pointer to testing.t. Testing.t is what enables, is a type that provides all the methods that you need for your test reports. I'll briefly talk about some of the methods that it provides, but this is all you need to get started with your automated test. Now you can ask that if you've used a framework called Maven, even Maven follows a philosophy like this. Maven goes by a famous philosophy called convention over configuration. So in Maven, if you have all your tests under a directory called source test Java, it automatically picks all the test files, and provided your test suite starts with the name test, just like how Go requires the test suite to follow underscore test philosophy. And it picks all the tests within the test file and it executes them. But you don't need a framework like Maven to write your test or run your test. That's something provided out of the box by the Go programming language itself. And if you are familiar with automated tests, having some test setup and teardown is very common before you actually execute your test. So that's something you typically accomplish using a unit testing framework like TestNG or JUnit. And for in Go, you don't need anything like that. For example, if you're familiar with JUnit, there are 2 kinds of setup and teardown you can do. One is something that you do at the beginning of the test suite, but there's also another kind of setup that you can do before execution of each of a single test. So in this example, I have shown this test setup and teardown only at the suite level. For example, hello underscore test as a test suite. And I have a test main, which is something that will run before the execution of my 2 tests, which is test hello and test world. I will show you in the next slide as to how you can have test setup and teardown at the test level, which is relates to your before test and after test annotation if you're familiar with JUnit. So in this example, test main is equivalent of your before and after annotation in JUnit. And I will talk about in the next slide as to how you can set up and tear down before executing a single test. So you can see that you don't need a framework, again, JUnit to do setup and tear down. Test main is sufficient. That's something that's given to you out of the box by Go programming language itself. There are other frameworks in the Go community like Testify. If you're used to writing tests like in a annotation fashion, like how JUnit does. But in my experience, I didn't have a need to use those frameworks, and this has been working beautifully for us. So we haven't used any external framework. The third point that I want to talk about is, I know I briefly touched upon this at the beginning of my talk, that Go doesn't have any support for assertions. And that's something that was done intentionally because, like I mentioned before, test code is nothing different from your regular Go code. So you don't need a new assertion library for you to report whether your test has passed or failed. You can use simple if-else logic, and you can use some of the methods that's provided by this testing.t type. You can look at the Go documentation, which provides detailed explanation of all the methods that's being provided by this T type. Some of the methods that you could use for reporting your test pass of error is a function that this testing package T type provides. And there's another method called fatal, where if you want to just abruptly end your test case because something crucial happened. For example, that's something like when you set up something and your setup actually failed. if your setup failed, there's no need or point in running your test. So that's when you want to abruptly end your test suite. So that's a use case for fatal. And another useful method is error. So error is something you can use when you just want to log an error, but you still want to continue executing the rest of the test suite. So these are a couple of useful methods that are available in this pointer testing.t object. Again, Go documentation is great for the testing package and in general for all the documentation, so you can get more information about these. So with these assertions being part, so lack of assertions in Go language is actually not a problem at all. There are, again, other frameworks that are popular in Go community. One is Testify, especially the require methods and Testify. That's something you can use if you're comfortable with using assertion rather than writing your own Go code. So there are a few other features that I want to highlight that are part of the testing package. So one such feature is a nested test or subtest. So in this example, you can see I have one high-level test called test table driven, but within the for loop, I have another test called t.run. I have only one subtest in this example, but you could have multiple subtests. For example, I could have another t.run subtest. The reason for when a subtest would be helpful to you is when you want to organize your related test in a single high-level test. So for example, you could test an API and you could have multiple use cases that you want to test against the API. So in that case, nested test is something that you could think about. The other cool feature that I want to highlight here is the table-driven test pattern that this test is illustrating. So this is similar to your parameterized test in JUnit. So if you have used JUnit, you could remember the parameterized annotation that you need to do if you want to have single tests and you want to pass multiple parameters to test a single test. Again, there's no need for all those annotations or frameworks. And table-driven testing is nothing fancy. It's, again, simple Go code. It's simple, but yet powerful. That will help you accomplish what you need. So in this example, I have one single test, but I want to test my single test against 3 parameter set. So I have a slice of struct, which has the input parameters. First is the name of the test, and then I have a couple of test parameters that I'm passing, and then I'm running a single test against these 3 input set. So this is very powerful because it clearly explains what you're trying to do, and you don't need any of those fancy annotation if you're coming from a programming language like Java using frameworks like JUnit. The third feature that I want to illustrate here is parallel. Tests by default run sequentially. So if you want to run your test in parallel, which is something that you would want if you want to reduce your test execution time in the pipeline, so you can push out your features faster. So that could be done by just calling this parallel method in this type object that I've been talking about in testing package. So this lets you run all the tests in parallel. So in this case, the 3 tests that's going to run in the for loop, they're going to run parallelly. So until all these subtests finish, the top level test table driven will not return. So you can see how easily you can run parallel tests just by calling this method without doing any additional work. So I think these are very important features and also very simple to use. So you can see how different writing automated tests in Go language is compared to other languages. The next topic that I would like to touch upon is mocking. I'm sure mocking is something you would have heard about if you have written unit tests. When you're writing a unit test, you want to mock other modules or packages that you're not testing or other external dependencies. There are multiple ways that you could write that you could mock these modules. One way is you can write your own mocks. So in the example that I've shown, let's say your test interface is what you're trying to mock. This is the module that you don't want to test. Then you could write your own you can implement the interface. For example, I have implemented that interface on an empty struct. So you can see that I have an empty struct, and then I've implemented the get and set methods. But I've also done it in a one level higher. You can see that I have made these methods get and set to return a variable like get mock and set mock, instead of actually having the implementation there, because this way you can control this variable as to what the value of this get mock and set mock should be. So you can test different use cases in your test. For example, you can also test your happy path in your code. You can also test error path in your code by adjusting this mock behavior. So this is very simple yet powerful to write your own mocks. But sometimes your interface could be huge, and writing mocks manually does not scale for you. Personally, I did not encounter this use case, but it's possible. So in that case, you can use a popular framework called GoMock. It's not part of the standard library, but it's still very popular in the Go community. And it also provides a mock generator tool where you don't have to manually write the mocks. You just run a command and it generates the mocks for you based on, and you mention the interface that you want to mock for. So that's done for you. And the third one that I want to talk about is a network called mock. So if you want to mock your external APIs, then you could use this HTTP test package, which is not part of a testing package, but it's a sub package within net HTTP that you could use to mock your external API calls. HTTP test kind of provides two kinds of support. One is if you want to mock the server itself, when you want your test to focus only on the client side, you can do that. But if you want to test the handler itself on the server, then you just want to record the responses, then HTTP test provides support for that as well. So you can you can go take a look at the Go documentation for HTTP test. You will have some good examples that will illustrate the different use cases that I mentioned about. Okay, so far we have seen what it takes to write test. Now let's briefly talk about what it takes to execute the test. So to execute test, if you've used in the other languages, automated test in other languages, like I said, you would predominantly run your test using a framework called Maven as part of the pipeline, but you don't need that. So to execute test in Go, all you need is the Go tool chain. So that's something that comes with you when you install Go language. Next slide, please. All right, so I have given some commands that will help you to understand how you can execute a test. As I mentioned, the Go tool chain comes in with you when you install Go language. So in Go test, like you've guessed, is the way you can run to execute your test. So the first example I have is Go test, which by default will run all the test files which has _test at the current directory. But if you want to run test files that are not at the top level directory but also internal directories, then you can use the next command, which is go test //. So Go test has a bunch of test flags that's very helpful and handy. So if you want to understand what are the test flags available for you, you can use go help test flag command that will illustrate different test flags that's available for the test command. One such test flag is -v. By default, Go test output that you get is very terse, but if you want verbose output, then you can pass this test flag -v. And another test flag is -run. This gives you control as to which particular test that you want to run. So the first example shows you that I want to run a test that it uses regular expression. So any test that contains capital A, please run that for me. And the next command that shows, this is related to the nested test that I talked about. So this runs all the tests that's called A1 under a test called A. The other useful test flag that's part of test is cover profile. There are a bunch of other code coverage related test flags, but this one will help you to generate the code coverage report for you. The name of the file will be cover.out. Again, so this is all given to you out of the box, so you don't need a plugin like Jacoco to generate the report for you. So now that you have your report, you need to analyze it. Now let's see what kind of support Go gives you to do that. So for that, we have another tool called Go Tool Cover, which will help you analyze this coverage reports. There are different ways you can analyze a report. The first one, Go Tool Cover -func, and the name of the coverage report you just created will just display the code coverage in the terminal itself. But if you're used to a user interface and if you want to view the coverage report in a browser, then you can have the -html flag, which will nicely open a new browser for you, and it will give you analysis of how much code coverage you have through your test. So these are all really good test flags. So this Go Tool Cover completely replaces tools like Sonar Cubes, because you don't need another tool to display your to analyze or understand your code coverage reports. So again, there are a bunch of other flags, test flags that are useful. So please feel free to run this command, go help test flag, to get an understanding of what are the other possible test flags that you have available. The last feature is very important, which is build tags. So if you've used a framework like Maven, you run your test in different phases. For example, you run your unit test, and then you build your code, you deploy your services, and then you run your integration test. So these are all two different phases in Maven, and you could have used different plugin. For example, Maven's default unit test plugin is Surefire, and for integration test is Failsafe. But you don't need anything like that. So here, if you want to control when you want to run your tests, you do it through something called build tags. So you generate your test and you create a build tag at the top of the file using this format that you need to follow, plus build and the name of the tag. And of course, it has to be commented out. When you do that, and then you pass the name of the tag that you just created. For example, in my example, I'm showing that the name of the build tag is build tag name. So it will run only if you specify this tags command or the tags flag to the test command. Otherwise, Go test will not pick up these test files. This is something you need, like I mentioned, when you want to run your API or integration test, because you want to make sure your services are up and running before you run your test. So all this is given to you, out of the box. You don't need other frameworks like in the Failsafe plugin that I mentioned to run integration test. Okay, so far I've been talking about support for unit tests. Now let me briefly touch upon what kind of test beyond unit tests you can write using Go language. Next slide. Thank you. So Go, Go does, using the testing package, you could write integration tests and end-to-end tests as well. It is true that you need to write, you have to write minimal Go code, but it's still possible. So you don't have to depend on a testing framework like Rest Assured to test your APIs. That's what we have been doing, and it has worked well for us. We didn't have a need to depend on a framework. The other type of tests that I want to briefly touch upon, which are again part of the testing package, is benchmark and profiling and example tests. You write benchmark tests when you want to analyze the performance of certain areas of your application. And profiling is something that you could use when you want to analyze how the system resources are being used. And the third type of test that you can write is example test, which is very interesting, and it's primarily used for documentation. So if you have analyzed or read Go docs, you could have seen a chunk of examples where you run a live example and see the results. That's actually being accomplished through this example test. So you can see that Go language does have support for not only for unit tests, but for other kind of tests as well. Okay, so with that, I am coming to the end of my talk. Having worked in Go for the past 1 year, I've been using Go for 1 year for the internal tool that I've been developing. It has completely resulted in a change of mindset for me. So my mindset is language first mode compared to learning a framework or a library. I'm not saying that you don't need a framework and library at all. Frameworks and library has its place, it has its own use cases. For example, if you want to write Selenium or a UI-based test, then it makes sense to use a framework like Selenium. But for most part, Go testing package and all the helper packages that it provides to write automated tests is sufficient to get started with writing automated tests in GoLang. Next slide, please. Because, like I said, Go philosophy is that Go test code is nothing different compared to regular Go code, and I firmly believe in that mantra. This has not only helped me in saving my brain power, but it also helped me tremendously to stay focused, and most of all, it has helped me to advance my career. And I think it will definitely apply to you as well. With that, I want to highlight that we have many open engineering positions in our company. So the link here will illustrate some positions. You can click that link and read more about it as the requirements are. But we also have a vibrant Go community within the organization, which welcomes new and experienced, and wherever your experience level is in Go programming language. So if you believe in New York Times mission and you want to support us, please come and work for us. So I think that's the end of my talk. I've listed some references here, which talks about the Go documentation and other links that I've used to prepare this presentation. Yeah, I think that's it. So thanks for the time to hearing me out. If you have any questions, I'll be happy to take it.
Awesome. Thank you, Thilak. I think that was a great presentation. I really like your key takeaways about, language first or frameworks. I think it's a good way to approach it. And also, the testing code being just regular Go. I always find, for me, I always find my starting point of learning is going at the test and then refactor, going from there to actually learn the code base. So good stuff.